Hi. In conceptual engineering design, the team does high-level engineering analysis to assess the high-priority requirements. It does it by expressing a performance specification in simple calculation terms, making a preliminary assessment of durability, estimating the rough cost of producing the product, assessing whether the design has any potential fatal flaws, and applying a decision process to choose which option to take into detailed design. The prediction of performance and reliability using engineering analysis is what differentiates engineering design from other types of design. It's a good idea to pick several of your potential conceptual ideas that look like they can deliver the required functionality. Why? Well, a few of your ideas may not actually be feasible, and you need to know that early enough to ensure that you have a set of feasible design options. When evaluating how a concept can deliver performance, a single performance criterion should be examined first. It usually works well for one team member to take some function and work through the simplified calculations of what the component or subsystem will do to deliver it. You take the output that you need, get the input values that are given or assumed. If you make an assumption, state somewhere what it is and why. Modify some parameter, assess the effect on the output that you want. And if you get what you need, then you've got a feasible concept. This process of iterative selection and testing of parameters is called sensitivity analysis. Your search for values of design parameters is based on whether the choices get you to the desired performance based on the calculation method that you're using. You're not trying for optimality. You're just trying to get close enough to see that this part of the design is feasible. All members of the team participate in design evaluation, individually first, and then with close communication as the design concept evolves. That's because there may be aspects of the design that interact with each other. Design considerations that start to appear include preliminary material selection, what components to buy versus build, and whether a modular design should be pursued. Modular designs are functional, but they're seldom optimal or elegant. Elegance in design comes when a component delivers more than one type of functionality. Talk to other members of the team to gain understanding and critique. Don't change something that affects another part of the design without discussing it first. Then you move on to other aspects of functionality and durability. Here you're trying to think of ways that the loading of the system might damage it. It might be structural loading, might be thermal loading, it depends. Use factors of safety to design out failure or reduce consequence, or as required by codes and standards. Don't go crazy adding contingency because this adds to mass and cost if the safety factor is too high. As soon as the geometry of the design begins to be important and you're modifying parameters, then it's time to use a CAD package. The design becomes much easier to modify and analyze with the simulation add-ons in tools such as SolidWorks, and the design becomes easier to describe. Potential synergies and problems also become more apparent. Once preliminary evaluation has been done for each subsystem, then it's time to get together as a group again to discuss each concept on its own. Have one person facilitate the discussion so that you are keeping track of what you're discussing and deciding with respect to aspects of feasibility, durability, and cost. Other people can take turns offering perspectives, and this is where the 6 thinking hats comes in handy again. Then you'll develop a decision matrix. It's weighted appropriately to determine whether a design is likely to be able to deliver the desired and required key performance, has no fatal flaws from a failure mode standpoint, is economical, and is achievable by your team to deliver. It's best to do the decision matrix development separately from your concept discussion meetings to reduce bias for or against a particular concept. The decision matrix is your way to compare the concepts and ensure that you have confidence that you're choosing the concept with the highest chance of success in your detailed design.